All the batteries that we work with are already here. They're already in Canada, they're already in the US. So we don't have to worry about importing new batteries, which is one of the challenges for some of the other historic companies that have been operating in the industry. Companies that are setting up domestic capacity, they still need time to ramp up and to get at scale in the market. Whereas for us, being a company that has deployed energy storage before, we have that advantage of we know the designs, we can go out and deploy and service the customer's needs.
Hey there, I'm your host, Justin Rice, the founder of Climate Tech Canada. The world needs more battery energy storage for the grid, for data centers, and for industrial facilities that are cutting their power bills and adopting clean energy. All of those batteries are expensive and carry their own climate footprint from mining and processing of raw materials. At the same time, we're about to have a massive inventory of batteries reaching the end of their lives as the first generation of EVs starts to retire. Our guest today sees those two problems as an opportunity. Moment Energy is taking retired EV battery packs and repurposing them for commercial energy storage with partners like Nissan and Mercedes-Benz. When a battery comes off an EV after 10 or 15 years, you might think it's done, but in fact, it still has around 80% of its original capacity. Now, that's not really useful for an EV where range really matters, but if you put enough of those together, it becomes years of grid storage waiting to be deployed. And unlike competitors that are sourcing cells from overseas, Moment's feedstock is already here in EVs across Canada and the US. Today, we'll talk with Sumreen Rattan, co-founder and COO of Moment Energy, about this second life energy storage thesis. We'll talk about how they've landed supply deals with some of the world's largest automakers and are now planning the world's first battery repurposing gigafactory in Texas. We cover the domestic supply chain opportunity, why data centers are opening a whole new market for second life batteries, the policy friction that's slowing energy storage down in Canada, and what it actually takes to build at gigafactory scale. And now, my conversation with Sumreen. Sumreen, welcome to the show.
Thanks for having me, Justin.
Yeah, I'm really glad we could sit down. I've been looking forward to this conversation for a while, but I'd like to really start maybe at the genesis of Moment Energy. So you and your co-founders built electric race vehicles together before starting the company. What did you see in that experience that you were like, hey, I think there's a business here in these batteries that nobody wants anymore?
Yeah, I mean, that is definitely the formative roots of Moment Energy when my co-founders and I were working on the electric race vehicle project. And what really caught our attention at the time was the fact that the batteries that we were putting into this vehicle were also donated to us by another battery company. So it was our first experience with the idea of reuse, and we had realized these batteries still had significant potential. Even though they weren't useful for that company, they were still very useful for us from an EV application. And while we were in this team, we actually had an opportunity there was a call for announcements, a call for proposals on what to do with EV batteries at scale once they start to retire. And this was a group in Hong Kong that was looking for submissions from people across the globe. So these two things really brought together that opportunity of, hey, there's something here. We need to look into this and see what can be done so these batteries don't end up in landfills.
Yeah, that's really cool. And I think for most people, like you think, okay, batteries at its end of life, it's done. But obviously that's not the case. So maybe just talk about like how does a battery storage system from Moment Energy come together? How much life is still remaining in these batteries?
When we receive EV batteries at the end of life in the vehicle, they typically have an average of 80% of their original capacity remaining. So for an EV driver, when they have their batteries, when they first buy the vehicle, they're able to get a full, let's say 400 kilometers on a full charge. But 10 years to 15 years later, that starts to drop down. And that's at the point when these batteries get removed from the vehicle. So even though they're no longer feeding that initial application, they still have that significant capacity left. And at that point, that's when Moment Energy comes in. We take these batteries and we bring them into our facility. We put them through vigorous testing. We're one of the only companies in North America with UL 1974 certification. So that means that the entire process of testing, grading, and sorting EV batteries has all been vetted and approved by UL, which is a certification body that's recognized in both the US and Canada. That really puts us in the best position to qualify batteries to now be converted from their original use in the EV to now being used in energy storage projects. and where we really put together our bread and butter with our battery management system and our way of handling and creating these safe systems is that we can use these batteries for another 10 years in energy storage projects.
Wow, that's like a substantial second life for a battery that had all these raw materials going into it. To extend that by another 10 years is like pretty significant.
Absolutely. Yeah, I think that's what surprises people the most is that, hey, I've already used these for 10 to 15 years in one vehicle. How is it possible you could use it for another 10 years? And there's some science behind it, but essentially it's the fact that you can stack as many of these batteries as you need to in an energy storage project. Whereas in a vehicle, if you want to top up your capacity, you're limited by space. You can't just insert more batteries in the body of a car.
Yeah, yeah. Throw a battery in the trunk. Yeah, that makes sense. If we zoom out a little bit, the battery storage market has evolved a lot since you first started the company. And now it seems to really be taking off, kind of moving from more of like this niche backup energy player to like basically core grid infrastructure. Help us get a lay of the land. What's changed in the past few years and really driving this shift in the market?
Sure. I mean, when we first started our company, the market that we were looking at was more so off grid and microgrid projects where we knew these batteries would be serving day and night operations, really displacing diesel generator use as they're being deployed. Now we have entered the grid market where we can plug our batteries into the grid. They are certified for use on grid, which was a really challenging milestone to hit, but we were able to become the first company globally to hit that milestone. So what's changed is that our target market for the last few years has been the commercial and industrial sector, where manufacturers and other companies are facing high demand charges when they plug in their operations into the grid and they're running all of their manufacturing lines. They're billed according to the maximum power that they're drawing from the grid. And that's where energy storage can really make a significant difference. We can use it in an application called peak shaving. We can help the customer save hundreds of thousands of dollars per year on their utility bills. And that is still a core focus. It's still something that's very much needed across North America. But now we have data centers that have come into the mix. And the use of AI and that need to scale and deploy data centers as quickly as possible has put huge stresses on the grid. So we see that as an additional opportunity where we can use our systems to help support the grid so we have the infrastructure to maintain our existing power, but also the additional power that we need in order to continue our day-to-day lives.
I definitely want to dive into the data center side of this later on. So it's interesting that kind of peak shaving ability makes a lot of sense from a cost perspective. For a buyer that's maybe evaluating a battery system from Moment Energy versus like another provider, fresh like new batteries, what's top of mind for them? What are they kind of optimizing for, and like how do you approach that pitch?
Sure. I mean, when we speak with customers, there's a few things top of mind, and that's what essentially forms our mission statement as well, which is to provide worldwide access to affordable, reliable, and clean power. So those are the three things that we've recognized that customers look for. They want to ensure that their electricity itself is affordable, that they can, if they're installing energy storage, that falls into the same bucket. Secondly, reliable. So ensuring that their operations can continue, that they don't have to face brownouts or blackouts. It's really a asset that they can depend on. So that's critical, and that falls into what we really prioritize in our system design. And thirdly, clean power. So when we talk about, if a customer has a choice between two energy storage solutions and one is using or sourcing retired EV batteries versus the other one, which is using brand new batteries, which have their own implications and emissions involved with the sourcing of raw materials. Two systems being equal, they will choose the one that is more sustainable and clean. And that's where we can provide that additional value of, hey, we are a sustainable company. We are repurposing batteries. We don't want to mine new raw materials when we have so many batteries that are already out there in the market that can service the energy storage application.
Am I understanding it correctly in that the sort of the emissions, and I would imagine they're kind of scope 2 emissions, scope 3 emissions maybe, that's a bigger driver than like a cost advantage?
Cost is definitely a part of the equation. When we sell our systems, our goal is to be 30% more cost competitive than other alternative solutions on the market. So that also plays a huge factor when the customer is deciding on which product to go with.
Yeah, that makes a lot of sense. And then on that price note, so there's been a ton of evolution in the battery space as well, like lithium iron phosphate cells, like all these kind of different battery chemistries. How do you think about the durability of that cost advantage? Like, is there a point at which that really narrows, or do you see this as like an enduring advantage over that?
We do see it as an enduring advantage, and that's why we put so much work into the IP side of things when we're developing a battery management system. That battery management system is intended to optimize the performance of second life batteries. So, where that allows us to also have another competitive edge is that in typical energy storage projects, all the batteries will eventually degrade from 100% state of health down to a certain, let's say 70% or 80%, and these cells start to come out of balance.
Okay.
With our systems, we already account for that day one. So we're optimizing for the differences in these state of healths and the variances in the battery cells so that we're able to hit that market competitive requirement of at least 10 years of service.
Another really interesting development recently was the US just hit a milestone, able to domestically produce enough battery storage capacity to meet their own demand. We've also seen redwood materials kind of pivot from recycling like the raw materials into this repurposed market. What do those signals tell you about where the market is and particularly like the competitive landscape? Like, how are you thinking about that?
What we're finding is that there's been more and more interest and requirements from customers, especially in the US, to have a product that meets the tax credit requirements that they need for deployment. And that does fall into having more domestically sourced materials, and in particular, what we call non FIAC or non foreign entities of concern materials in the product itself. So we are actually one of the companies that are developing products that meet those requirements. And this is huge for the industry. We're able to manufacture these in our facility in Canada, but we also have plans to open up the world's first battery repurposing gigafactory in the US, which services that growing demand to have a domestically sourced product. The other really cool thing about what we do is that all the batteries that we work with are already here. They're already in Canada. They're already in the US. So we don't have to worry about importing new batteries, which is one of the challenges for some of the other historic companies that have been operating in the industry. In addition to that, the companies that are setting up domestic capacity, they still need time to ramp up and to get at scale in the market. Whereas for us, with the batteries already being here and being a company that has deployed energy storage before, we have that advantage of we have the batteries, we know the designs, we can go out and deploy and service the customer's needs.
So you've landed this supply agreement with Mercedes-Benz. It's a pretty significant signal that a large OEM is committing their batteries to you rather than a recycler or something like that. Could you just unpack how that deal came together and like what's the pitch to them as well? Like how are they thinking about this?
Sure. Yeah. I mean, early on when we first started as a company, the very first automaker that we worked with was Nissan, Nissan North America.
Okay.
And that that really demonstrated and signaled to other automakers that there is something here working with Moment Energy. There's trust, and there's another company in the same industry that's already partnered up, so it de-risks the opportunity. So when we worked with Mercedes, it was actually an inbound lead for us where they reached out and said, "Hey, are you interested in working with us to repurpose our batteries?" So it was a bit of a different situation, and we've had a great relationship over the years in terms of sourcing batteries, putting them into our products, and deploying them. Now we have a huge Rolodex of automakers that we work with, and the pitch to them is that these batteries still have that significant potential once they retire from the EVs, and there's a waste problem at hand. These batteries, the automaker doesn't want them to end up in landfills or producing toxic waste. So it's an incentive for them to work with a partner that can take care of the batteries, ensure they're put to good use. And at the end, the automaker also has a product which is a fully circular solution that they can then deploy at their dealerships or their manufacturing facilities for energy storage needs.
Yeah, I was really interested in the supply chain kind of security aspect of that. You're essentially tapping into a domestic supply of battery cells, whereas other folks have to buy them from China or India or like wherever else and import them. What does that process look like to navigate those kind of foreign entity rules? And like, did that just like further tip things in your favor? Or was this kind of like a moving target as that evolved?
It's been a bit of a moving target in the sense that a lot of the rules around what's accepted and what's not have been constantly evolving over the last few months. So we've been keeping a very close eye on what the requirements are and essentially have fed those requirements into the designs of our products that we're developing. So it's at the front and center of the product design, and we're really excited to launch. We're going to be launching a product later this year that meets all of those requirements, which we think will be very exciting for the North American market.
Very cool. Okay. And then have these market changes in the US changed how you think about Canada as a home base and as a home market?
It does change in terms of who our target customers are. So in Canada, we actually see a huge potential in deploying energy storage in BC and Ontario. In BC, the opportunity came up rather recently in just the last 2 years because BC Hydro released an energy storage incentive program. And with that program, a lot of customers who originally couldn't afford to install energy storage, they are now able to install it because they get 80 to 90% of the capital cost back by enrolling in the program. So this has created a massive market for energy storage in BC alone. And in Ontario, we see that there's more potential because of the ongoing demand charges that manufacturers face in the province. So with our facility in Canada, we expect that the vast majority of products we create will be servicing the Canadian market, and there's markets abroad where we'll be deploying systems from the Canadian plant as well, which includes an upcoming project that we'll be deploying in Chile in South America.
It's a lot of exciting stuff on the horizon, it sounds like, throughout the rest of the year. Another interesting shift in the market has been EV adoption. And it's been slower than forecast in North America. We've seen some of the, kind of more legacy OEMs dialing back their ambitions. Do you see that as a real constraint on your feedstock and kind of sourcing, or like how does that kind of change the math in the business?
So, in terms of the math that we've done to date, it's all based on historic deployments of electric vehicles. Since we're waiting those 10 years, 10 plus years for these batteries to retire, all of our supply has already been forecasted. They're in vehicles today. So the real thing it changes is, how many batteries will retire from vehicles 10 years from now. But based on our projections, there's going to be above 900 gigawatt hours of batteries retiring by 2030 alone. So we see that supply isn't necessarily the constraint. It's actually the ability to take in all these batteries and repurpose them at that level.
Got it. That makes sense. Okay. I'd love to double click on the data center side. So this is, I mean, probably the most like dominant story in climate tech right now. It's completely changed like a bunch of different markets. I'd love to hear like, are they a real buyer category for you today? Is this still emerging? How are you thinking about this new kind of category?
The data center market is definitely an emerging market for us. We signed an MOU with SFU recently, which is to advance their supercomputer project by installing energy storage to support the power needs. So that's a very exciting project that's coming up. We see this as one of the entry points in Canada to support the data center industry. As far as the continuation of moving into more data center projects, we also have very large opportunities with hyperscalers that are deploying both in the US and Canada massive amounts of data centers where they require various sizes of energy storage. And we can help these customers achieve their power needs and also ensure that they're not putting a huge bottleneck on the grid and are able to thereby save utility demand charges in the process.
And in that agreement with SFU, and there were a couple of other partners involved in that, which was really interesting. You had like district heat, you had like AI load management. What are you hoping to kind of prove out or learn through that partnership?
Our goal is to show that these repurposed batteries being put into energy storage systems, they have such significant capacity and charge and discharge capabilities that they can be used for these high power applications like data center projects. So that's one of the things we want to demonstrate to the entire industry is that how powerful these batteries actually are and what they can achieve.
So you can kind of have this real world proof point you can point to and say, here's how they performed under real loads in a real environment.
Absolutely.
And then is there anything about those hyperscaler conversations that is different than other like customer segments you've been working with? Like, are there net new requirements? How are they thinking about the second life battery storage as a part of their stack?
I mean, in terms of the customers, what we find is that the manufacturing companies that we work with, as well as the data center projects, they're still ultimately looking for a reliable battery. That's the most important thing, is that they don't want to be in a situation where they have to shut down their operations or any of the data centers that they have running. So that's the first piece that they look at, is how reliable are these systems? Do they pass certification, that the bar for certification for those projects? Can they be used, and are they dependable? So these are the different things. But so what we find is that both customers care about the same things. It's just the scale at which that they will be installing the batteries. For data centers, they need a lot more of these systems that to be
Right.
installed to service their needs. Whereas for manufacturers, there's usually a typical size that we will deploy based on their energy needs.
Okay, so this is almost a step level change in the size of deployment you're seeing.
Yes,
Okay.
definitely. And with this SFU project, it shows that initial approach to deploying these. But when we go into the future, it's essentially how do we deploy hundreds and hundreds of our systems to support
Yeah.
the centers?
Got it. I'd love to unpack that a little bit more from kind of the like nitty gritty operational side. Like, so you mentioned kind of these off grid locations or deployments where there's like, you know, a shipping container size, maybe now the industrial and now data centers. What's been like the hardest part about going through those like step scale ups, or like maybe like big takeaways from your end about like going out and deploying this in the field?
I would say the initial piece of it is actually sometimes the toughest part, which is going through site requirements and acceptance, and ensuring that everything is ready from a construction standpoint on site. There tends to be significant delays in the commercial and industrial sector when we're working with clients for things that are generally out of our control. Like, is the site prepped? Is it ready? Or how is interconnection going? That's a really big piece of it, where we can get roadblocked, and it takes longer to close these contracts than some of the other ones that are out there. So I would say those are the challenges that we see, and that's something that we're constantly working on optimizing through more and more projects as we get familiarized. And that requires working with dedicated, reliable partners that can do some of that EPC work.
For maybe like your own team, what have been some of like the internal like learnings of going through those scale ups? I feel like a lot of startups out there are headed into that scale up phase, and you folks are going to like kind of go through that in the next, or are going through it. From maybe like a team perspective, what have been some of your big learnings?
What we found is that having some strong applications engineers on the team has really helped. And we have great ones at Moment that work hand in hand with the customer to ensure that deployment timelines are being met, that roadblocks are being resolved. And what we've learned is that building relationships early on is really important, especially as you're working with various regulators in the industry. So whether it's city permitting or working with HJs, authorities having jurisdiction that ultimately have the say on whether the battery will be installed or not. Those are all really important pieces to put together early on so that you don't run into issues once the system is ready to be deployed.
Got it. That makes a lot of sense. What's been your experience on that regulatory side in Canada versus the States, or even like in different parts of Canada? Like, are there areas where you found it's much easier to kind of go through that regulatory side?
It depends state to state. There's different
Yeah.
regulations. We do find that Canada as a whole is a lot more stringent than some of the markets in the US. Texas, in particular, is one of the states where it is easier to deploy projects as opposed to California, which has a lot more
Okay.
regulation. So it definitely depends on where you're doing the project.
Just going back to the gigafactory in Texas. That's a huge move to open a gigafactory and like operating at that scale. What's like the operational challenge in pulling something like that off that you think is maybe underrated, or people wouldn't know about?
I mean, it's never been done before. That's the
Right.
first thing. So to scale up to that level, it requires a lot of intention on how we're going to be bringing in this vast majority of batteries. how are we going to power cycle them and test them to put them into safe and reliable products. So it's definitely something that we intend to do in stages to ensure that we're doing it right and that we set it up for success at that gigafactory scale. So it's something that we will ramp up over the course of 3 years to get to that final output capacity.
Is there a particular capital stack that you had to put together to make this viable? What did that kind of capital stack look like?
I think so. In terms of funding, we have the support of the Department of Energy in terms of the $20 million grant that they provided to open up this facility. So there's their part of the funding. There's our matching funding to that grant as well. So that's really what puts together the overall project to be able to open up that gigafactory.
You mentioned the role of those application engineers. A gigafactory takes a ton of people to operate. What is that the talent side of that look like? Like, is that a constrained market for you, or how are you thinking about that?
The hiring side of things is actually one of the most challenging parts to scaling. We need lots of specialized technicians and engineers to come in so that we can really build up our capacity. And that includes battery engineers, which are very scarce in the market. So you have to seek out the right folks that love. We have some really great battery engineers in house that love batteries. It's amazing how much time and energy they could put into just figuring out everything that they can about different battery types. But that's one area, along with having specialized technicians that understand how to work with high voltage components. And there's a level of training involved from our side, but that is another area where we require hundreds of technicians, both in Canada and in our future facilities in the US, to really build up that manufacturing capacity. But those are the two high level spaces. Where another area where we are currently hiring is also electrical engineers. We want to bring on some more folks to help support the electrical side of the products that we're building.
Like rebuilding that manufacturing capacity on the talent side, I think is really interesting. I think we often think about like the factories, like, oh, we gotta like build these big factories, but you need people in them operating them who like know how to do this. And it's I feel like sometimes it's not even, you have the right degree. It's you have some lived experience actually like doing this in the field. Is there a balance between sort of that maybe like new grad fresh engineering degree versus you're looking to specific industries to kind of draw talent towards you?
We find that for parallel industries, that people who come from automotive, like working at different automotive companies, tend to make a really great fit at Moment as well. The best combination for us is people who have worked in a startup and worked at an at scale
Right.
facility, like an automotive facility, and they can really come in and show, okay, this is where we are now, and this is where we need to get to. So those are the type of folks that we're really looking for to come in and help us scale.
Yeah, yeah, which is interesting to think about, all these OEMs changing their EV plans, and I'm sure there's talent out there that has all the skills you're looking for and is now like looking for, hey, how do I keep working in this space if my company is dialing this back?
Exactly. And we see that there's also a big opportunity right now for scaling up our Canadian plant in terms of hiring people who want to move back to Canada, who have been working, that are Canadians that have been working down south, that are now looking for similar opportunities here. So we're creating this job industry, especially in Vancouver where it doesn't exist, that people can come back to and join and be a part of.
There's a lot of focus right now, at least at the federal level, around critical mineral strategy, the big electricity transmission build out, climate competitive, all this kind of stuff. And I feel like the talent side is almost assumed. Like we kind of just assume that it will follow if we kind of build all this out. I'd love to get your take on like, do you think this is an underrated part of those strategies?
I do think that there's more work that needs to be done to ensure that the academic institutions are actually training up staff to come work at companies like Moment Energy. And that means having dedicated and specialized courses on working with batteries, dealing with them, building larger systems. Those are the types of skills that they don't exist at a vast scale in Canada today. And even in the US, I think it's something that needs to be invested in.
Something that's really stood out to me, again, kind of going back to those like large national strategies that have been rolling out. Canada seemingly has been very slow to adopt large scale energy storage. Like, I think there's been a couple of big projects in Ontario now that are like utility scale, but it's like the biggest project ever. And it's like maybe like 400, 500 megawatts. From where you stand, what do you think needs to change to accelerate that market in Canada?
I do see that there's lots of bureaucracy and red tape that causes delays in these types of projects. Where we could find some successes if there's a fast track to deploy and vet companies so that these projects can be unlocked and commissioned. So this is something that we've seen with other projects that we've done in Canada, where the cause for delay was that fact that the city didn't have the approval, or there's some reasoning that was not typical in terms of other projects that we've done. So I think that's some investment that can be done on the really it's the municipal side to start, but also some federal push to ensure that that red tape isn't there.
Right, right. A bit of that kind of coordination.
Yeah.
And do you find there's a just like an experience or familiarity gap? I think a lot of municipalities just aren't familiar with it and are like, hey, we don't want to be the first people to do this.
I mean, it's been exactly as you described, which is that, hey, we haven't done this before. We don't want to be the first to do it. But like you said, there's lots of examples out there of cities that have done this. And I think looking to those and trying to find ways to expedite and ensure that we do have the power that we need to support the grid, as opposed to, fast forward 10 years later where we're now facing brownouts and blackouts at a high scale because we didn't invest in the technology on time. So these are the types of conversations that we're having every day. But I wish that there was a way to expedite the
Yeah.
process so that we can get our systems out the door.
Yeah, absolutely. And then on a grid level, my impression is that a lot of the utilities and energy regulators are still figuring out how to integrate batteries and specifically like flexible demand and demand response, some of that like two-way integration. Do you see that as a significant lever for more energy storage, or is it, that would be just be a nice to have when we actually just need to build out these utility scale projects as they are?
I mean, having those incentives in place definitely push customers to install energy storage sooner. I mean, having in BC, for example, even the energy storage incentive program alone was something that pushed customers and drove them to install systems. But if there was a change in utility structure, I think that would really incentivize groups to move faster.
Are there jurisdictions that you look to that are really doing it right? Like you mentioned Texas from like a project development side, but are there any others that come to mind? You're like, yeah, this is close to a model for others.
Texas is probably one of the main ones still that come to mind. It is a mix of ensuring that there's, again, there's less roadblocks in terms of actually doing the deployments and commissioning, but also having the incentives from an energy structure, an energy billing structure, where companies see the value in installing systems on site. And that's something that isn't necessarily implemented in all the different provinces in Canada, but in Ontario, because it exists, there is a drive and push from commercial and industrial customers to install energy storage. But it is more so the municipal delays that come in play to prevent those projects from being deployed quick enough.
Can you just say a little bit more about that, what they're seeing on the bill that would incentivize them?
Sure. Yeah. I mean, in Ontario, there's something called the five peaks model, which means that if you're drawing electricity from the grid during any of these five peaks in the year, you're actually being taxed at a high volume to use the grid at that time. So what a
Okay.
lot of companies do right now is they simply turn off their operations, which is not, ideal for a company that's trying to manufacture. So they'll turn off their operations, and then when that peak has gone, they'll turn it back on. Now, there's energy management system companies that exist which predict when these loads are going to come or when these peaks are going to come, and that's when they'll give instructions to these companies to say, "Hey, turn off your power if you
Right.
want to save some money." But if the companies have energy storage installed, they can turn off their power, and that can be done. It can be automated so that they don't see any difference in their operations. The energy storage kicks in, it gives them the electricity they need, and they've now bypassed this massive utility bill increase because of the correlation between the energy storage company and the energy management system that's in place.
Interesting. I feel like that's an underrated lever, particularly if you're thinking about the economic upside of clean electricity. Like if you can make that abundant and cheaper, like all of those businesses shutting down their operations can't be great from an economic growth kind of perspective. And I feel like there's a lot of like, hey, we need more generation. We need to like, building more generation is obviously a big part of it, but also just like the market and bill structures of how much does this cost? How accessible is it? It feels like an underrated lever for sure.
Definitely. Yeah. And I think that's something that a lot of customers don't actually have awareness of. They've accepted that this is their reality, but they're not
Right.
aware that they could look for a solution that could solve all their problems.
Very interesting. Yeah. I was really curious too. So because of that, a little bit of like that knowledge gap on energy storage, are there things that you find people tend to misunderstand about the space, or misconceptions that you find you're constantly debunking?
I mean, in terms of customer knowledge, there is definitely an education piece. Sometimes we'll be dealing with a customer that has a higher than average knowledge, and they're the ones that are typically asking us the questions on, hey, do you have
Okay.
this and this and this? But for the most part, it's our approach is that when we speak with customers, the first thing we'll do is ask for their energy bills. We'll take a look and we'll see, hey, does it make sense for them to install energy storage or not? How significant are their demand charges? And then from there, the piece that we have to be intentional about conveying is what is their return on investment? How does this really work from their balance sheet side? Because some customers can't always afford to put in an upfront cost for an energy storage system. So we're looking at ways to become more adaptable and creative. One of those ways is having an energy storage as a service model, so that for the customer, it's not as much of a hit when they install these systems up front. They can actually pay us a monthly service. Or in some cases, if we're saving them enough on their demand charges, those savings actually cover the majority of what they would need
Right.
to pay off the system. So for them, it's really no difference to their financial models. Everything looks the same, but they've essentially got a free battery on site. So these are some of the things that take time to educate the customer on, and there
Yeah.
can be confusion up front. But once we get it right, then it's almost a no brainer.
And I guess a similar question, but maybe on the investor side, like this, as you've gone and talked to investors, and you've like, Amazon Climate Pledge, I think is one of your investors. You got some like really great names there. What kind of misconceptions did you run into on that side of the conversation?
I mean, when working with investors, I guess this also falls into customers as well. But sometimes there's that question of, hey, how do these batteries compete with new batteries on the market? What is the core technology? What makes them match the duration? So those are things that they investigate early on to try and understand. Okay, what is your IP? How does this work? Generally, our investors, once we walk them through that portfolio, that's where they get really impressed. That's the reason why Amazon Climate Pledge Fund and Voyager Ventures and some of the other investors have invested in us because they know that we have the core technology. And usually the feedback we get is that we need to do a better job advertising that we've come this far.
Okay. Right, right. Okay, so they're looking at your like portfolio of IP, and that's like a big differentiator for them.
Definitely, yeah. And then the second piece I would say is the understanding of how many EV batteries are actually out there. So I think the initial
Oh yeah.
question is, hey, is there even enough supply for you guys to be a sustainable business? But once we show them the numbers on, hey, these are how many vehicles are out there, these are the batteries that are going to retire, there's more than enough supply. And that usually brings things to a close.
Yeah, that makes sense. Um, I guess if we look ahead, like if you're thinking maybe 5 years from now, what does it look like if everything goes right and Moment has won? Like how does the energy storage space look different?
Our dream is to have moment facilities across the globe where we're repurposing batteries locally and we're putting them into energy storage systems to support the local grid infrastructure. So that's what success to us looks like, is that Moment Energy is a household name, that we're trusted, that we're the go-to provider for battery energy storage systems worldwide.
Love it. Sumreen, thanks so much for spending some time with us. I'll close out. Any final ask for the folks that are listening?
Oh, my ask is that, to visit our website, look for job opportunities. We're constantly hiring. We're moving into a new facility this summer in Vancouver. So if you're interested in joining us and working with us, please don't hesitate to reach out.
Fantastic. Thanks again, Sumreen. Really appreciate your time today.
Thanks, Justin.